Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. Amazon Elastic Container Service, or ECS, is AWS's native container orchestration platform, designed with simplicity and tight integration into the AWS ecosystem. It allows you to run and scale containers across clusters of infrastructure without manually managing container scheduling or networking. ECS takes on the heavy lifting of orchestrating where containers run, how they communicate, and how they scale, freeing developers to focus on building applications rather than stitching infrastructure together. Beginners should think of ECS as a logistics hub. You bring packages, containers, and ECS determines which trucks, instances, or Fargate tasks to load them onto, where to deliver them, and how to balance the routes. This blend of orchestration and automation makes ECS a practical entry point into containerized workloads. At its core, ECS revolves around a few simple concepts: clusters, tasks, task definitions, and services. A cluster is the logical grouping of compute resources, whether EC2 instances or Fargate capacity. Tasks are running instances of containerized applications, defined by task definitions that specify what containers to run, their resource needs, and configuration. Services maintain tasks at a desired count, ensuring the right number of instances always run. Beginners should picture this as an airport system. The cluster is the airport, the task definition is the flight plan, the tasks are planes in flight, and the service ensures the correct number of planes are always in the air to handle demand. ECS supports two launch types, EC2 and Fargate. With the EC2 launch type, you manage the underlying servers where tasks run, gaining flexibility but also operational responsibility. With the Fargate launch type, you let AWS handle the servers, focusing only on tasks and their configurations. Beginners should see this as the difference between owning a fleet of delivery vans, EC2, versus outsourcing to a rideshare platform, Fargate. Both approaches deliver packages, but the choice depends on whether you want direct control or managed simplicity. Capacity providers in ECS introduce flexibility in how compute resources are allocated. They allow you to mix on-demand and spot instances when using the EC2 launch type, ensuring resilience and cost optimization. If spot instances are interrupted, ECS automatically rebalances workloads onto on-demand. Beginners should imagine a workforce of permanent employees on demand and part-time contractors spot. If contractors leave suddenly, full-timers step in to keep operations running smoothly. This blend ensures cost savings without sacrificing reliability. ECS scheduling distinguishes between service tasks and standalone tasks. Service tasks are long-running workloads, like web APIs, where the desired count is always maintained. Standalone tasks are run once or on demand, such as batch jobs or data migrations. Beginners should think of service tasks as restaurant staff always on duty, while standalone tasks are like temp workers hired for a single event. Both are useful, but services add stability while standalone tasks offer flexibility for short-lived jobs. Networking in ECS supports several modes, with AWS VPC being the most modern. In this mode, each task receives its own elastic network interface, making it a first-class citizen in the VPC with its own IP address and security group. The older bridge mode allows containers to share a host's networking stack, but it reduces isolation. Beginners should think of AWS VPC as giving every apartment its own mailbox and key, while bridge mode is like sharing a single communal mailbox. AWS VPC offers stronger security and clearer separation between tasks. Service Discovery integrates ECS tasks into DNS so microservices can locate each other dynamically. With ECS Service Discovery, Route 53 can automatically assign DNS names to tasks, making services discoverable by name rather than IP. Beginners should see this as a corporate directory. Instead of memorizing everyone's phone number, you simply look up their name. This abstraction is vital for microservices architectures, where services scale in and out frequently, and static IPs cannot be relied upon. Load balancing is another core integration. ECS services can register as targets behind application load balancers or network load balancers. ALBs provide Layer 7 routing enabling path or host-based rules, while NLBs offer Layer 4 speed and static IPs. Beginners should picture this as assigning customers evenly across checkout counters. ALBs can send shoppers to the right counter based on their purchase type, while NLBs route them quickly without questions. Load balancing ensures ECS tasks remain accessible and traffic is distributed evenly. IAM roles for tasks enforce fine-grained security. Each ECS task can assume a role that defines which AWS resources it can access, such as S3 buckets or DynamoDB tables. This replaces the risky practice of storing credentials inside containers. Beginners should think of this as giving employees access badges tailored to their job. The accountant's badge opens finance offices but not engineering labs. Task roles follow the same principle. Permissions are scoped narrowly, following the rule of least privilege. Secrets management integrates directly with ECS. Containers can retrieve credentials or configuration data from AWS Secrets Manager or Parameter Store at runtime. This eliminates the need to embed sensitive values in container images. Beginners should imagine secure envelopes delivered to employees daily with temporary codes. The codes change often, and no one is tempted to write them on sticky notes. This approach simplifies security and compliance, keeping secrets external and managed. Logging in ECS uses log drivers that forward container output to CloudWatch logs. Developers can standardize formats, set retention, and search across distributed workloads. Beginners should think of this as installing microphones in every meeting room and piping the audio into a central archive. If an issue arises, the recordings can be reviewed to pinpoint what went wrong. Centralized logging is a best practice that ECS simplifies through tight integration with CloudWatch. Health checks ensure ECS tasks remain reliable. If a container fails its health check, ECS automatically stops and replaces it. This keeps the desired number of healthy tasks always available. Rolling updates add another layer of resilience. New versions of tasks can be deployed gradually, ensuring traffic shifts only to healthy replacements. Beginners should compare this to swapping out employees on a shift one at a time, only keeping the register open if the new hire proves competent. The system adapts without disrupting customers. Blue/green deployments provide an additional safety net. By running new versions of services in parallel and switching traffic only after validation, ECS minimizes downtime and risk. While not as automated as in some other services, ECS integrates with Code Deploy to orchestrate blue/green strategies. Beginners should see this as opening a new restaurant location and slowly moving customers there once it passes inspections. If the new site fails, the old one remains open. This cautious approach balances innovation with continuity. From a cost perspective, ECS charges only for the compute resources used, EC2 or Fargate tasks, along with any ancillary services like load balancers or storage. There is no separate ECS fee. Beginners should think of ECS as a project manager. You don't pay them directly, but you pay for the workers and materials they coordinate. Cost efficiency in ECS comes from right-sizing tasks, leveraging Spot where possible, and scaling based on real metrics rather than fixed guesses. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Task placement strategies in ECS determine how workloads are distributed across available compute. The three main strategies are bin pack, spread, and random. BinPack tries to fill the least number of instances by placing tasks tightly together, optimizing cost but risking denser failure domains. Spread distributes tasks evenly across resources like availability zones or instances, maximizing resilience. Random simply assigns tasks without optimization, sometimes useful for testing. Beginners should think of this as seating people in a theater. BinPack fills rows one by one. Spread places them evenly across the hall, and random scatters them without pattern. Each strategy has trade-offs depending on goals. Autoscaling in ECS adjusts task counts automatically. Policies can scale services up or down based on CPU utilization, request rates, or even custom CloudWatch metrics like queue depth. This elasticity prevents both underutilization and overprovisioning. Beginners should picture a call center. When calls spike, more agents log in. When calls slow down, staff are reduced. ECS autoscaling works the same way, ensuring containerized applications stay responsive while optimizing costs. Spot capacity adds complexity, but ECS manages it with diversification strategies. By using multiple spot pools and mixing with on-demand, ECS reduces the risk of widespread interruption. If AWS reclaims capacity, ECS can reschedule tasks onto remaining resources automatically. Beginners should compare this to hiring temporary staff from several agencies. If one agency pulls workers unexpectedly, others still keep operations running. Diversification and interruption handling makes spot integration practical rather than risky. CI/CD pipelines are natural partners for ECS. Code Pipeline and Code Deploy can push updated container images from ECR into ECS clusters, triggering rolling or blue/green deployments. This automation ensures consistent releases and rapid rollbacks if problems arise. Beginners should see this as an assembly line for shipping products. Once a new design is approved, every box leaving the factory carries the latest version without anyone manually checking. ECS becomes the execution environment for these continuous delivery workflows. Observability is essential for ECS at scale. CloudWatch provides metrics for CPU, memory, and task counts, while X-Ray enables distributed tracing across services. Alarms can notify teams of unhealthy tasks or scaling failures. Beginners should think of this as a dashboard for pilots. Gauges show speed, altitude, and engine status, while warning lights alert the crew to anomalies. Without observability, ECS clusters may run silently into failures, so monitoring is part of responsible operations. Security in ECS builds on AWS fundamentals. Security groups restrict traffic. IAM roles enforce least privilege, and long-lived credentials should never be embedded in containers. Instead, task roles and temporary credentials keep secrets short-lived and scoped narrowly. Beginners should picture this as assigning temporary visitor passes instead of handing out permanent master keys. These measures minimize risk while enabling necessary access for workloads. Private image pulling from Amazon ECR is seamless in ECS. By granting tasks IAM permissions, ECS retrieves images securely without exposing credentials. This reduces attack surfaces compared to embedding Docker registry credentials. Beginners should see this as a library with staff access. Authorized staff can fetch books behind the counter, but no one else can wander into the storage room. ECR integration provides both convenience and security for container pipelines. ECS supports multi-account patterns by sharing ECR repositories across accounts and using VPC peering or transit gateway for shared services. Large organizations often centralize registries in one account and allow development accounts to pull images. Beginners should think of this as a warehouse that supplies multiple shops across a city. Everyone gets consistent products without duplicating storage, creating efficiency and governance across accounts. Multi-region architectures expand ECS resilience. Replicating images and services into multiple regions allows failover if a region becomes unavailable. Route 53 and global load balancing handle redirection, ensuring users connect to the nearest healthy deployment. Beginners should compare this to airline hubs. If one hub closes due to weather, flights reroute through another, keeping passengers moving. ECS designs benefit from similar redundancy for global availability. Common pitfalls in ECS include overpermissive task roles, missing health checks, and scaling based on the wrong metrics. For example, tasks might run with excessive IAM privileges, creating security risks, or lack health checks, leaving failures undetected. Scaling on CPU alone may miss bottlenecks in queues or memory. Beginners should think of this as relying on just one gauge in a car. Ignoring the oil light while watching only speed risks engine failure. ECS reliability depends on careful configuration. Cost controls in ECS emphasize right-sizing tasks and scaling to zero when services are idle. Over-allocating CPU or memory wastes money, while leaving test environments running overnight drives unnecessary costs. Beginners should see this as leaving all the lights on in a building when no one is inside. With careful monitoring and automation, ECS environments stay lean without sacrificing performance. Choosing between ECS, EKS, and Lambda is an important decision. ECS offers AWS native container orchestration with strong simplicity and integration. EKS provides Kubernetes compatibility for organizations standardizing on that ecosystem. Lambda is best for short-lived, event-driven code where containers are unnecessary. Beginners should think of this as comparing vehicles. ECS is a reliable sedan designed by AWS. EKS is a stick-shift car for those committed to Kubernetes driving, and Lambda is a scooter for quick, lightweight trips. Each is valuable in the right context. From an exam perspective, learners should focus on identifying ECS constructs and launch choices. If a question highlights clusters, task definitions, or task roles, it's ECS. If it mentions container orchestration without server management, Fargate is implied. If the scenario emphasizes Kubernetes, EKS is the match. Recognizing these constructs allows fast, accurate exam responses. Beginners should practice mapping clues like task definition or service discovery directly to ECS. In conclusion, ECS provides a pragmatic, AWS-native approach to container orchestration. It balances simplicity with flexibility, supporting both EC2 and Fargate launch types, service discovery, scaling, and integrations with AWS security and observability services. For learners, the message is clear. ECS is the go-to choice for containers on AWS when you want orchestration without Kubernetes complexity. By following best practices, least privilege, right-sizing, health checks, and observability, ECS environments deliver resilient, cost-efficient, and secure containerized applications at scale. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.